Hi, welcome back. So we're in chapter 2, story of math, on the outline area of mathematics. In this sub-outline, now we're going to talk about the geometry. The first thing we're going to talk about is the definition of point. What is point? Now, point is a primitive notion that models an exact location in a space. Imagine this is a space, what I call it a point. And important to see that this point has no length, has no width, has no thickness, nothing. So to this end, I need something to help me to define the identity of this point. This is the time where it's appropriate to introduce to you the coordinate system. And what do I mean with coordinate? It's something helped me to identify the identity of this point. So it refers to the point of a line, and later we're going to, of course, explain much more better about the idea of line. And it has the starting point here. I imagine I will call it the 0, and each unit it just passed by 1. I am using now the number system to try to capture the identity of this point. This point is defined as a 3 in terms of this A1. However, still I am unable to see exactly the position of this point in such a large space. So what is the best things to do? Perhaps to create one more axis which has to have certain property, and the point is both of them have to intersect at the point which we're going to call it the origin. So now I have created an identity for this P, and this P is defined as a 3, 2 in terms of the first axis of A1, the second axis of A2. But this is where the idea when I could contain now an integer numbers, where that means that have the inverse of this line by getting the minus value, and the inverse of the A2 as well by getting the minus values. And then I start to capture other points in different directions as well. Now, the idea of A1 and A2 could be expanded as well. So as long as I know the property must both of them have to be perpendicular, I could maybe create a new line. So here now I have this point is defined by 3 different axes or position. This is one type of coordinate system. It could be from the idea of defining from A1 axis or variable or dimension, A2, A3. It could be as many as AM number of dimension. Alternative, I can use another system. Fundamental idea of this coordinate system is a 2-dimension coordinate system in which each point is determined by a distance from a reference point and an angle. In terms of this A2, I call it point 2. And this may be, again, in terms of A2, the other direction here. I will just rely again on 1, 2. I'm not going to rely on the direction of the negative side. Now, I will first draw this line and this line here. The angle here, and there is one more angle here. So the first angle here, I will call it angle 1. And I will call the other one, which is this larger one, I will call it the angle 2. Now I have just created the system. It can tell me the position of this point inside this space in terms of this A1 variable or coordinate and the angle from a reference point. Now the second important element I think we need to talk about, it's the line. Now, line, you could look at it as a 1-dimension object. Basically, to define the identity of this particular line, I could rely on this point, and the other point happened to be again in this line. And the symbol, usually we use this 2 sides arrow. I might also write that way. Now, there are many types of lines. You might look at it in a sense. For example, I call it a tangent line. Imagine, just for now, later we're going to see, if there is a kind of a curve happens like that. So we know this tangent line. Also, we can make some other extensions about the property of this line by speaking about something called the ray of this line. So what does ray mean in particular? When I have from A moving to B, is different from having A moving to C. The important is to look at the directionality, but I know my reference point or sign point of A. So there is a directionality important here. Later we're going to see as a vector in other words. Also, we have something called a segment. If I would have AB, and usually segment is indicated by only a straight line like that, that means it's a segment. So AB, or also you can look at it as a BA, it doesn't really matter, both of them are similar. These are segment of line L And also we have something called the number line. Especially this is important idea when we look at axes or the dimension variables, as we said in here. So having, for example, this line starting from 0 here, and I'm going to use the integer, for example, having this point here and having another point here, I know for sure that x is absolutely less than y. Now, the next important idea is to understand what's so-called a plane. Now, in definition, a plane is a flat two-dimensional surface that extends indefinitely in both directions. This is the real number as we know now. If I write 2 here, this 2 indicate 2 dimensions we saw like A1 and A2. If I would have to write R3, that means it's 3-dimensional. So the idea of Euclidean plane often also arrays in subspace of 3-dimensional space. First of all, let's try to imagine what does plane look like. Surface. This is considered to be a plane. Now, to give identity for this plane, I could call it plane A directly, as I know the capital is referring. Also, I could call it plane A, B, C in terms of these 3 points. If there is one more point here, I call it D. Now, if it happens that there is an object, which we know it now as a line, happens to pass it through all these 3 points at line, I cannot call this plane as ADC. That is not possible because these 3 points happen to be on the same line. So the most important property that we have now, these 3 points happen to be not on the same line. Now, if you look at this plane, I will call this plane B plane. One important thing you might observe that both planes intersected each other on a line. Draw a line that passing only from plane B. Draw another line passing plane A, where all of them have actually intercepted at this point here. So imagine I have a point here, I have another one here, and one here. But this point in particular happened to be actually on A and on B at the same time. A line could be, for example, AO is a line, AC is a line, ED is a line. If I want to define this plane A in terms of points, this KDC define actually is equal to a plane A. AKC is exactly as I am indicating plane B. Now I could define a ray as well. So for example, starting from the origin of O, A ray, K ray, a segment. OC is a segment, ED is a segment, KO is another segment. But I know for sure now the idea is of looking at this, combining the point, combining into a line and then a plane. And we are using the number system to refer to them. Now coming back into the R2 perspective and R3, in terms of this line here, I've got A1 maybe, and this line here, I've got it A2. So this is R2, right? Also, I could look at it from A3 as well. So we know this is A1 and this is A2. There is one more here, perpendicular on A2 and A1 as well. I call it A3. Next, also, we'll be looking at something called the angles. It's the figure formed by 2 rays. For example, I will take ray OA, another ray, I will call it OK, for example. This is what's so-called or known as the angle. We call O as the vertex. But as well, we could look at angle that happen in the intersect between 2 planes through this particular line. So XY happens to be the intercept between the plane of A and B. From the perspective of angle, the intercept happens in here. This type of angle, we call it a diagonal angle. Next, we're going to be looking also at curves, surfaces, and manifolds. I will see you then.